Hey, 8th graders. This video is to help with the cricket assignment from Miss Christie in science class, one of your final science assignments, which is awesome. We are really almost done here. You've all done a great job. Let's not get too emotional here. Okay, I'm just kidding around. Don't worry, guys. I'm only going to cry like after June 18th, so don't worry. Don't worry about me. The cricket assignment, it says, please read the following article, then answer the questions in complete sentences. If you quote the article, please include the proper MLA in-text citation. You may need to hold control on your keyboard and then click the link. So the first question says summarize the article in complete sentences. I would like to, as usual, point out that it says complete sentences. I will not be writing complete sentences here for you to copy. However, you can listen to my words and put some of them into your own words. So I'm going to go over the article first and summarize some of the key points. There's only 4 questions. You can look ahead at them and try to listen out for that as you read the article. Number 2 is how and why have the crickets gone silent? 3, what are the immediate results of the crickets going silent and what are the long-term consequences of this? And finally, number 4, did the sound have a purpose? If so, what are the multi-generational consequences now that it is gone? All right, let's start this. Evolution sparked silence of the crickets. Males crickets on 2 Hawaiian islands simultaneously, so at the same time, went mute in just a few years to avoid parasite. Populations of a male cricket on different Hawaiian islands have lost their ability to chirp as a result of separate but simultaneous evolutionary adaptations or changes to their wings. The changes, which allow the insects to avoid attracting a parasitic fly, so a parasitic fly would be one that gets inside of them and destroys them, occurred independently over just 20 generations and are visible to the human eye, a study reveals. I'm right here. The findings could help to shed light on the earliest stages of convergent evolution, when separate groups of populations independently evolve similar adaptations in response to natural selection. So what that is saying is that 2 groups of crickets that were located in 2 different places had the same adaptation or change to their bodies. Male field crickets are known for their chirping sound, which is produced by scraping their wings together across one another. The wings' veins form special structures that make the vibrations that we hear as a cricket's song. The mechanism is like rubbing your fingernail on the file of a comb, says a study leader and evolutionary biologist. The nightly serenades lure in females and facilitate reproduction. That is key. That is key. One of the questions is, does the sound have a purpose? Yes, it has a very important purpose. The purpose of the sound is to lure in the females. And then there can be more reproduction, which leads to more babies. And crickets want to have more cricket babies to keep their population going. Unfortunately for the males in Hawaii, the chirping also attracts a deadly parasitic fly, Ormia orachia. I'm probably not saying that right. The fly larvae burrow into the cricket and grow inside, killing the host when they emerge a week or so later. Both species are likely to have arrived in Hawaii at the end of the last century, the cricket from Oceania and the fly from North America. To protect themselves from their new enemy, large numbers of male crickets on the Hawaiian islands of Kauai quickly stopped chirping. So if the flies are attracted to the chirping, one way to avoid the fly burrowing in the cricket and then killing it is to stop chirping, therefore not attracting the fly. The change seems to have caused a mutation that altered the shape of their wings, making them incapable of producing the chirping noise. The feat was achieved over less than 20 generations, a mere evolutionary blink of the eye, and with the crickets living only a few weeks, a very rapid process. By 2003, a study by Marlene Zook at the University of California, Riverside found that up to 95% of male crickets on Kauai were no longer able to chirp. The mutation had erased almost all the wing structures that helped to make the sound, leaving the wings flattened but still airworthy. So they could fly still, but they didn't make noise. Just 2 years later, in 2005, male crickets on the island of Oahu, which is 101 kilometers from Kauai, also began to fall silent. Today, about half the males on Oahu are chirpless. His team was intrigued by the existence of silent mutants in more than one population. So, see, 2 islands. On both islands, the crickets are now silent. The researchers suspected that the flatwings had simply migrated to Oahu from Kauai, probably by hitching a ride on boats or planes. However, it turned out that while the Oahu crickets too had flat wings, they were very distinct from those of their Kauai neighbors. The difference is noticeable even to the naked eye, with the Oahu crickets losing many fewer chirping structures than those on Kauai. So what that means is that on the 2 separate islands, the wings had changed on both species of crickets, but they had changed in different ways. So they didn't migrate, they both adapted. Both populations just adapted in a different way. Evolution in action. This evidence suggests that the mutations happened independently on both islands, making the Hawaiian silent crickets an excellent example of convergent evolution, says evolutionary biologists. Although evidence for convergent evolution can be seen throughout the natural world, it is difficult to catch it as it happens. The study shows that superficially similar convergent solutions to attacks by parasites attracted by sound can evolve in radically different ways. The genome can create similar results using very different sets of genes, so that's why we saw 2 different kinds of wings. They didn't create sound anymore, but they looked different. So different that in a cricket, even a human could tell the difference. Didn't need to be under a microscope. Bailey's team is now working to pinpoint the genes involved and understand how they interact with the rest of the cricket genome. Trezenga says that, besides identifying the genes, another exciting avenue for future research will be to investigate how the loss of chirping affects the ability of females to choose their mates and the consequence this has for the evolution of the population. So that was another question. What were the long-term consequences? Well, if females are no longer attracted to the males due to the lack of chirping, there's probably going to be less reproduction, and then there's going to be less cricket babies. But let's go through and talk about the questions. Number 1 was to summarize the article. So I'm not going to write everything for you, but we need to talk about in this part is convergent evolution. That is evolution that happens in 2 places in the same way at the same time, much like these crickets. You're also going to want to talk about, obviously, the crickets and how their wings evolved. And you're going to want to talk about why, which was because there was a parasitic fly that was attracted to the chirps and would kill them. All right, let's look at the next question. Let's go back through the article, remind ourselves. How and why have the crickets gone silent? Well, we know how, right? Wings change. You're going to need to put that in a complete sentence. This is part of evolution. Why did they do this? They don't want to attract parasitic flies. Complete sentences. Don't forget, these are not complete sentences. What are the immediate results of the cricket going silent, and what are the long-term consequences of this? Well, the immediate result is that less are getting killed, and also attracting less females. And that leads to the long-term consequences of less crickets over time. Remember, if the males aren't attracting females for reproduction, they're not going to be able to produce more crickets. Did the sound have a purpose here at number 4? If so, what are the multi-generational consequences now that it is gone? Yes, the sound did have a purpose. We know that. Yes, the purpose was to attract females. Put it in a complete sentence, don't forget. And if they can't do that, their population is going to dwindle because there's going to be less crickets born. So this is really a conundrum. This is a problem for the crickets because if they chirp a lot, they may get invaded by a parasitic fly that's going to kill them. However, if they don't chirp and they don't mate with a female, they're not going to be able to continue on the generations of crickets. I know they don't think of it like we do, like we're not continuing on the family name here or anything, but you know, for population growth and to keep your species alive, that is important. So anyway, this was a nice, simple assignment. I thought it made a lot of sense. I hope the video helped you, and having it read aloud might have helped some of you. Good luck getting it all done. If you have any questions, just let me know. Thanks. Bye.